This is section 8.7, base E and natural logarithms. Our objective today is I can solve logarithmic equations involving base E and natural logarithms. An irrational number is a decimal that doesn't stop or repeat. Today, the irrational number we're going to be talking about is E. So natural base, or E, is the value 2.71828, and that number continues to go on forever and ever and ever. It doesn't stop and it doesn't repeat. Now, a natural logarithm is an exponential function with the base of E. Natural base and natural logarithm are inverses. They're opposites of each other, which means that the graphs reflect over the line y equals x. So just like addition and subtraction are inverses, then that's the same way it is for natural base and natural log. So we can write exponential equations in logarithmic form, and we can write logarithmic equations in exponential form. And this is sometimes very helpful when we're wanting to solve this type of equation. So in example 1, we're going to be doing some practice with taking exponential equations and writing them in log form. So in example A, we have e to the x equals 8. So the first thing we're going to do is write log base E of 8 equals x. And this is just rewriting exactly how we did when we went from exponential to logarithmic form, log to exponential form. The only difference is we have that little base of e. And then we can actually write log e as just ln, or natural log 8 equals x. And that's our final answer. Same type of deal on the second one. First, we're going to go ahead and we're going to write log e of x equals 5, following that same pattern we've used before. And then we can change that log e into the natural log of x equals 5 for our final answer. Same type of example on C. We'll start out with log e of 9 equals x. And then we'll change log e to natural log of 9 equals x. Let's take a look at example 2 when we're going to be taking the logarithmic equations and writing them in exponential form. So we have natural log of x equals 0.7741. So first I'm going to take the natural log and I'm going to write log base e. We have x is equal to 0.7741. Now I can go ahead and write e to the power of 0.7741 equals x. And we have exponential form and our final answer. Same type of deal on B. We'll go ahead and write log e of 10 equals x. And we can rewrite this as e to the power of x equals 10. And that's our final answer. And we have our third example. Again, I'll change natural log to log base e of x equals 2.1438. And then we can rewrite that as e to the power of 2.1438 equals x. We can still use our log properties. Even though it's natural log, it's going to work the same way. So here I'm going to use my power property. I'm going to move my 3 so that it's 10 to the third power, so that I have natural log 10 to the third power minus natural log of 8. And remember that our subtraction can go to division, so I'm going to have natural log of 10 to the third divided by 8. And then I'm actually going to evaluate 10 to the third power, which is going to give me 1,000. So I have natural log of 1,000 over 8. And I can even go a step further and divide 1,000 by 8 and get the natural log of 125. And we're not going to evaluate here because all they wanted was for us to write it as a single log. On example 2, we're going to go ahead and do the same type of thing. We have natural log of 40, which we can't do anything with yet. We're going to move our 2 so that we have plus natural log of 1/2 squared plus the natural log of x. And now since this is addition, I can go ahead and be multiplying these. So I can have natural log of 40 times 1/2 to the power of 2 is 0.25. So multiplying 0.25 times x. And then we can simplify a bit further by multiplying 40 and 0.25 so that we have the natural log of 10x. And then with our last example, we'll go ahead and move our 6 using the power rule. We'll move our 2 using the power rule so that we have natural log of 8 to the 6th power minus natural log of 4 squared. And then remember with subtraction, we can write this as division. So we have natural log of 8 to the power of 6 over 4 squared. And 8 to the power of 6 is going to give us a really big number. We have natural log of 2, 6, 2, 1, 4, 4 divided by 16 because that's what 4 squared is. And if we actually divide that, our final answer is going to be the natural log of 16,384. So natural base and natural log actually undo each other, and we're going to use that property to be able to solve each base e equation and round to the nearest 10,000th. So in example 1, the first thing we want to do is actually get the e section by itself. So the first thing I'm going to do is add 5 onto both sides so that I have 4e to the negative 2x power equals 8. I'm then going to go ahead and divide by the 4 so that I have e to the negative 2x power equals 2. And then to get rid of the e, I'm just going to add an ln to both sides, a natural log to both sides. And that's going to make it on the left-hand side where the natural log and the e are totally gone, and all I'm left with is negative 2x. And then I still am going to have that natural log of 2 on the right. I can divide both sides by negative 2 so that x is equal to the natural log of 2 divided by negative 2. And then I can actually put that directly into my calculator. And when I round correctly, that's going to give me x equals negative 0.3466 is my final answer. In example 2, very similar steps. We're going to go ahead and add 12 to both sides so that I end up with 3e to the 4x power equals 15 plus 12 is going to give me 27. I'm going to divide both sides by 3. And if I divide both sides by 3, that's going to give me 9 on the right-hand side so that I have e to the 4x equals 9. I'm going to take the natural log of both sides, and that's going to make it to where my natural log and my e are gone. I have 4x equals the natural log of 9. I'll divide both sides by 4, and again, I can put this directly into my calculator, and if I type in ln of 9 divided by 4 and round correctly, that's going to give me x equals 0.5493 is my final answer. Our last example, we'll start off by subtracting 8 from both sides so that I have 4e to the power of negative x is equal to 9. And next I'm going to go ahead and divide both sides by 4. So I have e to the power of negative x equals 9 over 4. I can take the natural log of both sides so that natural log and my e are gone. So I have negative x equals the natural log of 9 over 4. To get rid of the negative, I'm going to divide both sides by negative 1. So when I type this into my calculator, I'm going to end up with negative 0.8109 for my final answer. So the last example we'll be looking at is continuously compounded interest, and E is actually used in this equation. Our equation is A equals PE to the power of RT. So we're going to read this, and just like we did before when we were looking at compound interest, we're going to try and figure out which letters we have and which letters we have to find. It says, when Angela was born, her grandparents deposited $3,000 into a college savings account. Alright, that's going to be my principal amount. That's what was originally deposited. So P is going to be equal to $3,000. And the savings account pays 4% interest, so we know that that's going to be R, the annual interest rate. So R equals 4%. Remember, we do need to move that decimal so that it's 0.04. And then they want to know what will the balance be after 10 years. So T, talking about years, is 10. So when we go and look at our equation, the only value we're missing is A. So A is what we're solving for. We're going to plug everything else in. So we have 3,000. Remember E, we're going to leave that as E because that's actually a number. And then raised to the power of 0.04 times 10. And I can do a little bit of simplifying here. I can do 0.04 times 10, and that's going to give me 0.4. So I have 3,000 e to the power of 0.4. And then I'm actually going to go ahead and put e to the 0.4 into my calculator. So you should have a button for that. You'll have to locate it. And that's going to give you 1.491824698. Remember, we don't want to round to the very end so that our answer is the most accurate that it can be. And then we're going to multiply by 4,000, or by 3,000. And then our A is going to be equal to $4,475.47.